everyone, welcome to today's session. Let us start by giving you all a quick brief on what Octanet is. Tech Octanet is a budding startup headquartered in Bhubaneswar, specializing in IT solutions across diverse sectors including e commerce, real estate, automation, and personalized business application. Our primary focus is to provide affordable services to startups, aiding them into their digital initiatives. In addition to our core services, we are expanding into the corporate training sector, aiming to equip future corporate employees with a solid foundation. We also address student needs by identifying academic project requirements, internship opportunities, and offering comprehensive solutions. We are proud to be incorporated as an organization with the Ministry of Corporate Affairs, registered with MSME, and approved by AICTE for internship programs. Also, our commitment to quality is underscored by ISO 9001 2015 certification, ensuring that every project we undertake reaches highest standards of excellence. Okay, thank you so much. That was all. Let us now stage our instructor and start today's session.
Hello students, welcome to the Python Development Workshop Day 1. Am I audible? Okay, I guess I am audible. So let's start. So since this is the day 1, I'm going to tell you what all things we are going to cover today and what all things we are going to cover in the next coming sessions. So on day 1, we will cover an introduction on Python, difference between the interpreter and compiler, Python ID setup. We'll also come on to the variables and some of the part will complete of the list as well. Also, we'll try to see up the built-in functions and the conditional statements as well. On the day 2, we will have more elaborate discussion over the list. We'll see tuples. We'll see some of the operations that we perform on the list and the tuple, and we'll also see the loops on the day 2. Then on day 3, we will see the dictionary, we'll see the sets, we'll see the how you can create your own functions. Ex- Apart from it, we'll see the recursion portion also on the day 3. On the day 4, we'll see the file handling, exceptional handling, and the classes and objects that fall under the objective orient programming language. Okay, so if my screen is visible, I will start the compiler and the interpreter. The very first thing that comes into our mind is how all these programs are running inside our machine. So basically, we have a few compilers and the interpreters or the machines that translates our code and is converted into a machine language that basically our machine understand. It gets like compiled, or it we say it gets executed and we get a return. But whenever you see, the return code is always in our language, like the language in which the user can understand. So typically there is also a translation between the machine executed code and the human readable code. So coming on to the compiler versus interpreter. Compiler translates your code written in high level language into machine code at once before program runs. So the very thing that should be kept in mind is that the machine code translates your code written in the high level programming language into the machine code at once. That means whole of your program gets compiled at once. Coming on to the next line, before your program runs, whereas in interpreter translation, each level program statement one by one. That means interpreter compile or execute your code line by line. That means each line will be executed at once. Whereas in your compiler, your each block or your entire code is executed at once. Here one line is getting executed at once, and in case of compiler, all your code is getting executed at once. The second point Or the second difference that comes into the picture is compiled code runs faster than the interpreted code. How? So when I told you that in a compiled compiler, all your program, all your code will be executed at once. So whatever the errors will be there will be displayed at the very last. In case of the interpreted code, each line will be executed once. Whenever there is an error, that error needs to be resolved first, and then the rest of the program will be executed. So this compiled code compiler will take less time to execute the code and will display the errors at the very last. Whereas the interpreter is going to take your code line by line, executed, is going to resolve the errors line by line, and at the last whole of your code will be executed. Coming on to the compiler displays all the errors of the compilation as I told you. On the other end, the interpreter displays all the error line by line. Whereas now coming on to the fourth point of difference, we have compiler is based on translation linking loading model, whereas interpreter is based on interpretation model. This is something that we can skip as of right now, because this has connection with the various other languages and other models. Okay, coming on to the example, like which all programming languages compiler takes over and which all programming languages interpreter takes look. So as we are studying the Python, I should tell you that Python is an interpreter. Python uses interpreter. Whereas for the compiler, I have the examples given here. Compiler is used by C, C++, C Sharp, Java, Scala, whereas interpreter is used by PHP, Perl, Ruby, JavaScript, jQuery, etc. Since these are the languages that commonly uses the compiler and interpreter to execute their code. Now we will see how Python compile and execute your code, right? Okay, so Python, if we don't see the text, you see this flowchart here. You have your code editor. Code editor can be anything. Right now, I'll be using the Google Colab. You can have the Anaconda, and you can have the VS Code extension with Python or any other editor of IDE that Python even provides. So, in code editor, you write your code, right? Once you write your code, you save your code with the extension .py. That becomes your source code, the file which contains the extension .py, right? Now this source file, when you run this code, or when you run the source code, this get Python interpreter convert this into the bytecode, right? This bytecode is now given to an operating system that basically contains your arithmetical logical unit, your control unit. So some of the operation parts of the, or some of the working part of it, whatever the instructions you would have given in your code, will be executed through the operating system or the CPU through the Python virtual machine. Python virtual machine is a machine that makes your code independent. That means anywhere, if your code with .py extension is there, the operating system will execute it with no errors or the possibility of not executing the code. Okay, so coming on to the if you read this, it's just displaying what I told you here. Python virtual machine makes Python platform independent, as I told you right now. Also, you have in Python you have various modules imported. You have various things that you can convert into a that will be converted into a bytecode with the Python interpreter. Now we will see how your CPU and the main memory with the storage devices work to save your work. Okay, so coming on to the how your storage devices, how your main memory or the RAM and the CPU works to grab your work. So basically, we have two types of softwares in our system. We have a system software and we have application software. Whenever you go and purchase a machine, there are two types of software that are available. One category is of system software that is already installed in your system or in your machine when you purchase it. And the very important and the vital point that needs to be kept in mind is this: the system softwares are necessary to keep your device or your machine in a good and a running condition. If any of the system software is not properly working, it can affect your system. Some of the example of the system software that I should give you is: it can be a file explorer, it can be a recycling bin, it can be disk manager. Okay, so these are some of the system software that are responsible to keep a machine in a good and proper way to make your work easy. So coming the second category of the software is application software. So whenever you go and purchase a machine, you always have some criteria in your mind that for what purpose are you purchasing this machine. So for a different kind of machine, there are different softwares that are already installed, or when you bring your machine, you try to install them. So when if you bring a laptop, you and you have in your mind that you just have to use for a college purpose, you just have to have that some certain software should be there. Like, you should have a proper, it should have a good space, it should have a good uh, MS Office installed and other things. Whereas if a person who is like into a research or is into a specific field, he or she might look for something else as the specification for the machine. So the software that are installed in the system after once they are purchased based upon the needs of the user are known as application software. Some of the examples for the application software are your MS Office, your it can be any of your specific uh, uh, like any specific system software like if I say coming on to the research, we have a console, we have Figma for the editor and all. So these are some of the examples of the application software. Okay, so there's a question that what is a persistent data. Okay, coming on to the persistent data. So whenever you do your work in a system, your work is not properly stored if unless until you have saved it. So there is a work or there is a space inside a system known as cache memory. This memory space keeps a record of the things that can be used very certain. Like, there are certain files, there are certain work that you use certainly, like very frequently you use that. So this is kept in a cache memory. Then you have a main memory. Main memory is the space where your work will be stored until and unless only till the power is on or the system is switched on. Whenever your system is switched off, the data from the RAM vanishes away. And to keep your work permanently stored, you have a storage devices that can be a ROM, that can be floppy, that can be hard drive, that can be in your laptop. It's coming in the form of SSDs. So this is the place where you can store your data permanently. So coming on to the question again, what is a persistent data? So the data that remains stored inside your system even when the power is off is known as persistent data. Okay. So the last question that comes in with this slide is how and when CPU executes the statement. So there is a small flowchart depicting a relation between the main memory and the disk storage. So main memory is basically we can say it as a RAM, random access memory, and the disk storage can be like assumed as of now as a ROM, read only memory. Okay. So operating system, the application that's running the data for the application. Okay, so main memory is just going to store the work that is presently in use or it was previously in the memory when you were doing the work. And the disk storage contains the system software application data, everything that you have stored permanently inside the system. So the CPU executes your instructions from the memory. CPU uses a program counter to keep a track of which instructions to fetch next. So there is a program counter that takes up the responsibility of tracking that which instruction is to be fetched up next and needs to be executed. The CPU sends a request to memory for the instruction. The CPU then decodes your instructions in the control unit. The CPU carries out whatever the task is required inside the file and in your data and displays the result. Coming on to the main memory, also known as the random access memory or the RAM, stores data and instructions temporarily while your computer is switched on or isn't running. The CPU can access the data in main memory randomly. That means it will randomly can access the data. It does not need to follow a certain principle where it's going to fetch up the next data. The CPU uses the cache to determine if the data is already present before accessing the main memory. That I've told you that before accessing the main memory, it has a cache memory that see the cache memory contains the work. If it is not containing the required instructions and the work, then it is going to go to the main memory to fetch up the things if it is there. And if it is not there in the like RAM also, then it is going to see that whether it is present in the storage devices or not. Now we have the storage devices coming up. So computers have both primary storage and secondary storage. So the primary storage is basically your RAM or the main memory, and the secondary storage devices or the like hard drives, or you can say your SSDs and everything fall into the category of secondary storage devices. Secondary storage devices are used to permanently store your data and your work. The CPU uses addresses and data buses to connect and communicate with these memory devices. So this like if I tell you in more detail, the storage devices or the secondary storage, like speaking more precisely, your secondary storage devices contains a good space, like it can be your 512 GB SSD. Nowadays 1 TB of SSDs are even coming up. So they contain a huge amount of, they can store a huge amount of data. For a computer or for a CPU to fetch up the data from the storage devices, it needs to communicate properly. If there is a communication gap or the lag between the secondary storage devices and your CPU, a wrong instruction could be fetched up. To avoid this condition, your CPU uses the uh, like cables or the buses, data buses, and uses the proper address. Like if you go into a better very deeper section of the operating systems and the computer architecture, you'll find that in a secondary storage devices we have a proper address given to each instruction, so that whenever there was a call to fetch up a particular instruction, that address could be delivered and a particular instruction is only going to fetched up. Okay, so a very last line is that CPU uses caches to keep frequently using the data that is close by, so it does not have to wait for a data to be retrieved from the main memory. So basically what this line is saying is that CPU tries to keep up the data and the work that are frequently in use in the cache memory so that it could be retrieved fastly. Okay, students, do you have any doubt till here? This was the very basic of what I taught, but I guess you should know this basic since it's going to play a very vital role in the deeper understanding of how these things work and how memory is fetched up and everything. Can somebody in the chat section please reply that it is clear till this point? Then I can proceed further. Okay, students, I guess till here it is not such very complex, but I guess you should know it just because these things like lay the foundation for any programming language that you learn or any if you go for higher studies in the computer science and other things, it plays a vital role there. Okay, so just let's revise and take a quick overview over these topics and then we'll move ahead. Then we'll basically see over to the variable part and list and everything. Okay, just in the chat section, can somebody please reply that it's clear till this point, since it's not just me studying, and I don't want a monologue to be happen here. Okay, so I'm assuming from my side that it is clear, and we'll just have a quick overview about your study, and then we'll move ahead with the variables. Okay. Okay, so as I've told you, compiler runs your code at once, interpreter runs your code line by line, compiler gets all your errors at the very last, and then interpreter basically have all of your things executed line by line, and then we have compile code will be run very fast as compared to the interpreted codes. The languages that uses the compiler are C, C++, C sharp, Java, Scala, and others also. Interpreters are basically used by PHP, Perl, Ruby, Python, JavaScript, jQuery, and etc. Many more. Then we saw how your Python codes get compiled and executed. So Python compiles and run your source code in the following manner. You write your code in a code editor and you save it with the .py extension. Then your source code get converted to a bytecode using the Python interpreter. This bytecode basically runs by the control unit or the arithmetical logic unit using Python virtual machine. This Python virtual machines make your Python platform independent. Then coming on to the how your CPU, main memory, and the storage devices works. So then we saw over there that there are two types of softwares inside your system or your machine: system softwares and the application software. System softwares are basically the software that are already installed in your systems and are similar for each devices, whereas the application softwares are the softwares that are there inside a machine or a particular system based upon the need of the user. Then we saw what is a persistent data that remains in your device, that remains inside your machine even when your system is switched off, is known as persistent data. Then we saw how and when CPU executes the statements. We saw how CPU fetched up the instructions from the cache memory. That if it did not found the instructions in the cache memory, then it go to the main memory. If it does not found anything in the main memory, then it takes the instructions from the storage devices such as your SSD, hard drives, and other. So okay, so should we start with the variable part? Can I just have a thumbs up or something? Okay, so anybody else has done with any other programming language, or this is the first language that you are studying? Students, can you please reply that should we go ahead with the variables and everything? Or there's anything that is unclear to you? Okay. So since there is no reply, we'll go ahead with the variables. Okay. So what is a variable? In any programming language that you study, you require a place where you can store your information. So this place where you store your information or your piece of data is known as variable. Variables are used to store the data which can be manipulated later on. Okay, it may contain any number of letters, digits, or the underscore characters. They must begin with a letter, and no special symbols or integers should be used as the very first character of the variable name. Python is case sensitive. That means for lowercase and the uppercase characters are significant, meaning they have different value in the Python interpreter. The variable name should not be a keyword. That means whenever you are going to give a variable name, you should keep in mind that it is not a reserved word or a keyword that is already in used in the Python. Then we have white space is not allowed when you have two words as a variable name. The variable must be meaningful, as carefully chosen variables make your code readable. That means if you keep your variable name more specific to what they are basically going to use in the program, it is going to make your code more readable. We will use lower camel case as the first letter of every word is going to be capitalized except the first word. For the example, here we have two words total marks, so the letter M of marks is going to be capital, else all the letters will be in lowercase. Okay, so let's see some of the practical part on to the variables. Okay, so if we have, okay, so uh, these three upper commas are used to like have your comments in the multi-line. So if I have what are variables? Okay, so variables are the containers that are used to store data. That are used to store data. Also, one thing that I need to add here is, and then in Python, we do not need to add the type of variable explicitly. That means you do not have to declare it before. Okay. Okay. So if we close this comment and we go ahead with the code again, if I have a variable name x, let's say we have a value stored in it as 10, we have a y variable and it contains the, let's say hello, it's a string. And then we have a z which contains the value is 3.14. Now if I just print all of them, if I print y, okay. Okay, so it has stated that x stores the value 10, your y stores the value hello, and your z stores the value 3.14, that is the value of pi. Now coming on to the part where we'll see how you can identify the type of variable. So your Python supports various data types including integer, a string, your boolean, and more. Okay. Now, if I say a is a variable that contains the value 5, b contains the value 2.5, c contains the value, let's say, hello, and we have a d variable which contains the true. Okay. Then, if I print all of them, if you print type is a function here that's going to tell you which type of variable is this. Okay, so similarly, we are going to print for every variable. Okay, let's run this. Okay, so it's saying that your A stores the value that belongs to a class of integer, your B stores the value that belongs to a class of float, your C stores the value that belongs to a class of string, your D stores the value that belongs to a class of boolean. Now we'll see some of the rules that should be kept in mind while we are naming our variables. Students, if you guys have any doubt, you can just type yours. I'll surely try to resolve it. Okay. Very first rule we have is that variable name must start with a letter or an underscore. It should not start with any integer special symbol. Second rule we have is that the rest of the name can include letters, numbers, or underscores. Then we have variable names. Names are case sensitive. Then we have a very important rule that variable name should not be a keyword. Okay. So if I have valid variable to 1, and if I start say sorry, okay. So these are basically the valid ways of naming a variable as it is pertaining to all the rules that I mentioned above. Now we'll see some of the invalid examples. Okay, so if I name my variable as one variable is equal to, let's say if I give it as a 4. Okay, sir. We have already been told that your variable name must already only start with a letter or an underscore. It should not start with any integer or number or any other special symbol. So this is not the correct way of defining a variable. Let's see one more example. If I have this is also not a valid name to define a variable. To define a variable that contains two letters, I should only use the underscore between them, or I should not use any space between them. Okay, so these are some of the examples of the invalid data ways of defining a variable. Okay, now let's come on to the type function. The type function is used to determine the type of variable. So if I say, now take the example from here. Type of variable A, simply write here type A. Then we'll write type of variable B. And C. Then type of variable D. Okay, let's run this. Okay, so it is saying that A belongs to a class of type of variable A is class integer, that means it belongs to a class of integer. Then type of variable B, then type of variable C, and then type of variable D. Now we'll see how you can use comments in Python to make your code more understandable and readable. Okay, so comments in Python. Comments in Python are used to explain the code. Are used to explain the code. Python supports both single line and multi-line comments. print single line comment starts with hashtag whereas multi-line comment. Okay, I'll just say that this is a multi-line comment. Okay, multi-line comments are enclosed in triple quotes. Okay, so this was all about the comments in Python. Now you see how the uppercase characters and the lowercase characters in Python are significant. That means how they both carry a different meaning and value. We'll use the order function or the ORD function to get the sky value. Sky value of a character. We'll use the order function to get the sky value of a character, and similarly we use the character function or the CHR function to get the character from a sky value. And we'll just see the example. If I say we have a character as A, okay, and I'll just print ORD of character. Let's name this character as character 1. I'll just have a character 2 defined here. That is going to keep small a. I'll just print the order for this also. The order is going to give me the sky value. Okay, let's run this. So see, the uppercase letter A and the lowercase letter A are carrying the different values. Hence, they both are significant to each other. Now, if I print CHR, and I'll just provide this 65 and 97. Okay, this should probably return me the characters. That means small a and big A, small a and capital A. Sorry. Okay, that's not this. Okay, so 65 is given for a capital A, and the 97 is given for a small case A. Okay, so let's come here back. Now we'll start with the identifiers, literals, and tokens. So, user defined alphanumeric words that can be your variables, functions, your classes, module, and other objects, they are called as identifiers. They are called as identifiers because they're used to identify a particular data that is stored inside it. Then we have raw data is stored inside a variable and we can't split them. That means the data that are stored inside the variables can't be split more. That can be your numeric literal or can be your string literals or the boolean values. Then we have tokens. Tokens are the smallest unit of program and they contains your keywords or identifiers and your operators. Then coming on to the comments, I told you comments in Python can be your single line comment, can be your multi-line comment. Comments are basically used to write your code in a more make your code more understandable and readable from the user point of view. And then we use the hashtag for a single line comment. For the multi-line comment, we use the triple quotes. So the multi-line comments are enclosed inside triple quotes. Okay, so coming on to the debugging. Debugging is the process of finding the errors inside a program and resolving them is known as debugging. The process of finding errors and resolving it is basically it's basically what we call as a debug your program. So there are types of errors. So the types of errors that are there, your syntax and semantic errors, your runtime errors. So the syntax error is that when you are using wrong syntax, when you are using a wrong format of a programming language, then when the compiler results into an error known as syntax error. Then we have the semantic errors where invalid logic is written that cannot be that the compiler is not able to execute it is known as semantic errors. The runtime errors are the errors that the compiler encounters while the program is running. So what are functions? So the functions are the block of code that is reusable. Function will be executed when it is called. It can take any number of arguments, which is optional, and it can return a data. Okay. So functions are the block of code which are reusable. That means you can use the block of function anywhere inside your code. Then function will be executed only when it will be called. Until unless your function is not called, it is not going to get executed. Also, function can take any number of arguments, which is optional. That means a function can take up the arguments also. A function can not take up the arguments as well. Then we have that functions can return data or function may not return data. Functions may return some variables or something or may not return the variables or may have some values stored inside the function that can be used later on. So this was about the variables. Let's try to do some more examples and then we'll move ahead with the conditional statements. Okay. So if I write this piece of code, if I have a variable a, let's say, and if I say, and if I write an expression that 10 is equal to 3. Okay. If I have a variable b that will store that 10 is greater than 8. Okay, then I have the variable c which says that 10 is greater than or equal to 12. I have a letter variable d that says that 13 is less than or equal to 10. Then we have a variable e, let's say it says that 100 is not equal to 24. Is not equal to 24. And I'll just print all of them. Since These are the relational. They are using the relational operators. Their output will be printed in the form of boolean. Print A. And is like right. Print B. Correct. Print C. If I write print B. So 10 is not equal to 3 and hence it has written into the false. So 10 is greater than 8, it is true. 10 is greater than or equal to 12. 10 is less than 12 but is not equal to 12. 13 is less than or equal to 10. 13 is not less than or equal to 10. 100 is of course not equal to 24 and hence it has resulted into false. Now coming on to the next question. If I say if I have a variable a, let's say, and I write 2 and 3. Okay. So then 2 and 3. Okay. We have a variable b that says 2. Okay. So we have a variable c that says 2. And I have a variable d that says 2 star 3. And if I print all of them, a print b, print c, okay, I will mark this. So 2 and 3. This and is for and operator. This for B we have used the operator. It is a OR operator. 2 and 3 is a XOR operator. Okay. So basically your all the 2, 3, 1 will be converted into binary code and then they are going to have these operations operated over it and then the result will be displayed. Okay. So students, do you have any doubt till here? Students, do you have any doubt? Okay, so I've taught you the basics of the ID setup, your compiler, interpreter, and we have also talked about the ASCII values, your variables, commenting in Python. Do you have any doubt till like from any of these topics? Students, do you have any doubt till here, till this variable part? Sky values, comments in Python, interpreter and compiler, ID setup and everything. Okay, I guess you guys don't have any doubt, so we'll move ahead. We are going to start with the built-in some of the built-in functions and the conditional statements. Okay. So Python has a lot of functions and libraries, modules defined already inside it. So we'll basically see some of the built-in functions in Python. We have the eval function, we have the input function, we have the composition function, we have a print function, type function, round function, we have a type conversion also, we have the minimum and the maximum function also. Then we have the power function, then we have a random number generation function. So these are some of the built-in functions that are there inside the Python. We'll see them once we are we will be programming them. Then we'll see each of them. Now, coming on to the conditional statements in Python. First conditional statement is if, else, and elif. These are the three statements that are used in Python for defining the condition inside your code. If statements helps to control the execution of program based on the Boolean expression result. If your condition inside the if block is true, then the code inside the if block will be executed. Else, code inside the else part or the elif part will be executed. If clause is mandatory statements where elif and else clause are optional. That means whenever you're going to define a condition, you also have you always have to use the if clause. Else clause and the elif clause are not mandatory. That means if you have used the if clause, this is not a mandatory condition to use the else and the elif clause only also. But if you have used the elif clause or the else clause inside your code, you definitely have to use the if clause. If clause always evaluated first. That means whenever you define your condition, your if clause is always evaluated first. If it is true, then the statement of if block will be executed. Otherwise, the first elif or the else block will execute if available. Only one block of statements can execute each time. That means when if block is executing, the else block and the elif block will not execute. All statements within a clause end when the indentation ends. That means the statements that are defined with the particular indentation will only be executed and their execution will stop as soon as their indentation ends. Then we have the conditional logic if, else, and elif. Suppose if you see in this flowchart diagram, if I have a start here and I'll just print a statement that enter a number that is less than 10. If this number will now be input, will now be user will enter this number, and if this number is less than 10, print what an obedient servant you are. And if this number is not less than 10, if it is not greater than 10, then we'll have to stop the program. Now we'll see the syntax of this program. We have a if keyword, we have a condition defined here inside the Boolean expression, and we have the statements under it. Then we have a else block defined. Remember, else block does not contain any condition. Elif block will contain a condition. And then we have a chained condition. Chained condition, that means you are going to have the elif block also defined. Now we have a if, we have the statements under it. If we have a elif, we have the statements under it. We have a else, we have the statements under it. The if block and the elif block contain the boolean expressions, but the else block does not contain any expression. Now we'll see the nested conditional statements. Okay, so the nested, from the word nested, means that the conditional statements that are defined inside one conditional statement is known as nested conditional statements. So we have a if defined here, we have an expression also defined for it. We have the statements under it. Now this if has an else here. This else contain another if else. Now this if else is known as a condition, is a conditional statement that are nested inside this else. So this is a nested conditionals. There is a separate if else defined for this else. Students, do you have any doubt till here? Students, do you have any doubt here? Please give a thumbs up in the comment section. Students, I guess you don't have any doubt. So we'll move ahead. Okay. So we'll move ahead. Okay. Now we'll see the practical. Number one, we have the if else statement. The if else statements allow you to execute a block of code if a condition is true. Otherwise, it executes another block of code. Now let's see the syntax. Okay, I'll just have an example here. Let's see if we have a variable x that has carries the value 10, and if this x is greater than 5, print x is greater than 5. Else we'll just simply say x is less than x is less than 5. Let's run this. Okay, since our value was 10, so x is clearly greater than 5, and hence if block of code is executed. If I just come, so here 1 is less than 5, and hence x is less than 5 is printed. So in the example we saw that the condition x greater than 5 was executed for x is equal to 10, and the if block of code was executed. Now we'll see the nested if else statement. Now, if I'll say if x is greater than 0, I'll have another if else defined here that says if x percent 2 is for divisibility is equal to 0, print it's a even number. Even number. Else print it's an odd number. Or now we'll write the if for else part for the very first if, print x is not a positive number. Let's say x is not a positive number. And I'll just run this code. So x is equal to 10, It's an even number since it is divisible by 2. Let's if I write here 11. I'll run this. So x isn't it's an odd number. If I write minus 1, I'll run this. X is not a positive number. Now we have the very famous codes. One is of grading system and the other is of leap year. Now before that we'll write a syntax for the if, elif and else. So like we'll write the syntax for this. We have a if, we have a condition defined here, we have a colon, we have the statement under it. Okay, now we have the elif. For elif we have a condition, and we have the statements under it. We have the another elif, we have a condition under it. Okay, then we have the statements under it. Now we can have any number of elif statements we want. Now we have the last, we have the else, and we have the statements under it. Okay, I just have this. If I run this, now we have a two codes. One is the grading problem, and the other is a leap year checker. So let's start. Suppose if I have a variable that says score is equal to 35. Okay, I have a if score is greater than or equal to 90, then print grade A. Then we have a elif. Let's say we define if I say score is greater than or equal to 80. These are the very famous problems that one encounters while you study. Print grade B here. You can take the choice of your like how you want to modify this code, but this is how you simply can define. Okay. Now we have the another elif defined. Just copy it from here. You students try to write the code as much as possible. It will make you more efficient in resolving and encountering the errors. This is for 50. Now we'll have the elif condition for marks that are greater than or equal to 70. Then we'll have the elif condition for marks greater than or equal to 60. We'll have the elif condition for marks greater than or equal to 50. Okay. Now we'll just change the grades. Okay. Now we'll just have the else condition defined. Else print grade F. Okay, let's run this. So for marks 85, the student has got a grade B since 85 is greater than or equal to 80, but it does not fall into the category of greater than or equal to 90. Similarly, if I check for, let's say, 53, we have a grade E. Similarly, if I write for suppose 41, we have a grade. Now we'll have a leap year check. Students, do you have any doubt till here? Do you have any doubt till here? Okay, so move on to the next program, that is our leap year checker. Let us say if I have a year equal to 2025, okay, and I'll define a if condition here. Okay, year percentage 4 equal to 0 if year percentage 100 equal to 0. Okay, then I'll going to check the again condition, that is if year is percentage. Percentage basically going to is used for the divisibility. It checks for the divisibility. We'll print that this is a leap year. I'll explain you the context of the program as well. Okay. Then I have a else. If I print year, yeah, I'll add the year. Year is not a leap year. Is not a leap year. Okay. Now I have the else part for the second if we'll define print if print year is a leap year. We will have the else part for the very last one defined. That else print year is not a leap year. Okay, so let's understand this program. We have a year, we have the year value as 2025. Now in the very first if we'll see that whether it is divisible by 4 or not. If it is not divisible by 4, we'll straight away this code will straight away go to the else part with the last and say that it's not a leap year. If it is true, it is going to get executed for the second if, that whether it is divisible by 100 or not. If it is divisible by 100, that means it is a leap year. From these two conditions, we can straight away say that this is a leap year. If this is not true, remember, if this is not true, we can simply say that this is a leap year since it is divisible by 4. Now, if it is divisible by 4, if then it is divisible by 100 also, then we will say that whether it is divisible by 400 or not. If it is divisible by 400, that is then it is definitely going to be a leap year. If that is not the case, then your separate divisibility with 4 and 100 does not guarantee that your particular year is going to be a leap year, and hence with this else part it will be printed that this is not a leap year. So this was about the leap checker program. Now let's continue this. So 2025 is not a leap year. Let's check for the 2024. So 2024 is a leap year. Let's check for the coming 2028. So 2028 is a leap year. So students, do you have any doubt till here? Okay, so we'll move ahead with the list part. Do you need any revision of the any of the topic that we have discussed till here, or should I move ahead with the list? Okay, so we'll move ahead with the list. So list. So list Python objects can store all types of data. Like we have integer type of data, we have a float type of data, we have a string boolean. And so list is a type of data, is a type of variable, or is a type of data type which can store multiple types of data, multiple types of data types. Your list is a mutable type of data. Your list is a mutable type of data. That means you can modify once your list is created. That means you can add new elements, you can change or update the elements that are already defined. Then we have a that list is orderable. List is orderable. That means it has got the elements are stored inside the list have got the indexes. These indexes list in Python we have the zero based indexing from the forward, and coming from the backward we have the negative indexing. So the elements that are there inside the list are modifiable and can contain duplicate data. That means they can contain the duplicate values. We can access the elements on a list using index which starts from 0 to n minus 1. We can use the list constructor to create an empty list. We have got a different ways to create a list. You can create an empty list using the square braces which contain no values inside it. You can create a new list, or you can have the elements already defined and you can modify them. Then we have you can use the constructor to pass the data inside it. Now, if I say that there's a list, my list one, which points to the my list. So this my list is going to contain the elements that is contained in the my list. Both my list and the my list one are pointing to the same object. Now, if I say we have, I have a list named students, which contains the list inside the list. We have four small lists which are contained inside the parent list. We have a first list that has got the index 0 that has the elements 1 and a comma Amit. Similarly, we got the second, third, and fourth elements. We can iterate on the list using for loop. So, you can iterate on the list using for loop. Since in list or any other data type that we'll encounter in the future, such as dictionaries, sets, tuples, we'll find that it is easier to iterate using for loop since you know the number of turns that a particular loop has to execute. Whereas in coming on to the fact where if we use the while statements, we have properly have to define the conditions. We'll see loops in the next session, but just for the timing, you can remember that for loop need for executing the for loop you have to have the define. You should know how many iterations you have to follow up rather than if you're coming on to the while loop. While loop is a conditional loop where you need to have a condition defined for executing that piece of code. Under while loop, if you come, your while loop will run until unless your condition is true. If whenever your condition becomes false, your while loop will be executed off and the whole code will move to the next. Now you can use the enumerate function to iterate on a collection with index. We'll see this in the lab. Now we have the list functions. Okay, coming on to the list functions. Suppose here we have a list name my list. So this len function is going to tell you that how many elements are there inside the list that has got the name my list. Then we have my list dot append red. That means your my list will be my list is going to have the next new element added red at the very last position. My list dot extend 22 comma 33 is basically going is used this extend basically is used to add a dictionary. So this 22 and 33 is also going to add at the very last position. Mylist dot count 3. This will count the occurrence of the data 3 inside a list. Mylist dot pop. Mylist dot pop function, this here it is written dot pop 0, will remove the index at the given, will remove the element at the index 0. Mylist dot remove function will remove the particular item from the list. Mylist dot reverse function is going to reverse the items in the same list. It is not going to create a different list, but it's just going to reverse all the elements that are present inside that list in the reverse order. Then mylist.clear is going to clear all of your elements that are present inside the list. Then we have a del keyword. Del keyword, we have a del, then mylist, start, and an increment. This will remove this piece of code is basically going to delete the uh, like whenever you want to delete any numbers or any data that are at a particular sequence or at particular index, then you can use this code. Here start and end are basically the indexes given. And remember, when whatever you want to be like, whatever index you give for the end one, this index is not included. Only index from start to the end minus 1 will be included. This increment is basically used that how many elements in our indexes will be skipped between the star and end. Then del mylist is going to delete or remove the complete list. Then we have a mylist dot insert 1 comma hello. This is going to insert the word hello at the index 1, and else all the elements after it will be shifted by one index. Then mylist.sort is going to sort your list in the ascending order. Mylist.sort reverse is equal to true is going to sort the list in the descending order. Even you can do it without using this reverse is equal to true. Simple, you will define the mylist, and then you will have this dot sort function that will sort in the ascending order. Then this you can, like, you can simply sort this mylist dot reverse to bring it in the descending order. Then we have mylist dot sort function where key is equal to length. Here key is equal to length means that on what basis your list will be sorted. So any doubt till here with the list functions? We'll move ahead with the list comprehension and the other list functions in the later classes. Do you have any doubt till here? Okay, so let's move ahead with the list. We'll see how you can create a list, and we'll see several applications of the list functions also. Okay, so let's move ahead. Okay. Okay, now we'll see how you can create a list. So just simply I'll just write my list is equal to 1 comma 2 comma 3. Suppose I have the elements and I just print this list. Okay, so it has printed the my list that contains the elements 1, 2, and 3. And then we have the type of my list. So my list belongs to a class of list. And since I've already told you, list is a type of a data type that can store multiple values of different data types. You can change the elements, you can add the elements, you can remove the elements. Also, you can have the duplicate values inside a list. Now we'll see how you can create a empty list. Alright, my list is equal to, then we have my list dot append 1. And I'll just print my list. So first I created this list that is empty. Now I have, using the append function, I have, like in life, I have included two elements 1 and 2 inside the list. Now you see how you can print each element inside of a list. We'll use simply for I in my list, print I. Okay. So here for loop, here I is iterable variable, and commonly here it is pointing to the element inside the my list. Then we are going to print each element that is present inside a list. Okay. Now we'll see how you can do indexing. Okay. Suppose if I write print my list, I've told you, since it's a zero based, we'll print the very first element will have the zero index, and for the timing, remember that the last index is to have going, the last element is going to have the index -1. If I'll just print this, just control the center, you'll find that the very first element is 1, so it's printed, the last element is 2, and hence it is printed. Now we'll see the len function. If I print, len function is going to tell you the number of elements that are there inside the list. So we have 2 elements inside the my list. Students, do you have any doubt till here? Okay, so I'll just continue again. So let's have a brief introduction and then we'll close up the session. So here we here we got to know that list can contain an list is heterogeneous type of data type. That means it can store values of multiple data types. And then we come on the list is mutable, that you can change and modify the elements. List is orderable, that means it has got the indexes. You can access the list elements of the list using indexings. It follows zero based indexing. You may create the list in the using the list constructor, and you have got many other ways in which you can create the list, and then you can append the elements also. Then we saw the list functions. Here the list functions are basically len function is going to tell you the number of elements that are there inside the list. Then we have then we saw append function, extend function. We'll see each of these functions in a very detailed format in the next session. But for the timing, you should at least know the basic functionality of these functions. We saw the count function is going to count the occurrence of a particular element. Pop 0 is going to remove the element its index. Dot remove function is going to remove the element from a list. My list dot reserve reverse is going to reverse the list. Then we saw the sorting in a list. Then we saw you can remove the particular series of elements using the start, end, and the increment factors. Then we saw how you can insert a particular element at the very index. So this was all about it. Students, do you have any doubt till here? I guess if you don't have any doubt, so we can end up this session here. Thank you for joining in. We'll see you in the next session.